You guys are on your textbook page 234, blue notebook page 229. We're going to just use quadratic models to solve problems. So the very first example they've given us in the textbook is a graph. It says a slingshot has been fired, and this graph models the height that the rock is at over a certain amount of time. So time is in seconds, and we put time on our x-axis. So we'll know it's in seconds here. And we'll say height is in meters. Okay? So they've given us a scatter plot, several different coordinates. If I take a look, I can probably create a line of best fit going through it, something like that. I can continue it. What's important, they want us to make a quadratic equation to model this graph. So, in other words, we have to make an equation. We could start by putting it straight into standard form, vertex form, or factored form. Those are the three different forms we know. I'll write them down here at the bottom. We know of our standard form, y equals, and we have our a x squared plus bx plus c. That is our standard form. Should have put that on top. There we go. We have our standard form. We have our factor form, which is y equals a x minus r, x minus s, factored. And finally, we have our vertex form, which is y is equal to a x minus squared plus h and k. So if we take a look here, we have three different models that we can make equations with. We're going to use one of these three models to start. Okay, we're going to try to fill in either the a, b, and c in the standard form, the a, r, and s in the factored form, or the a, h, and k in the vertex form. We're going to take a look at the graph they've given us, and we're going to try to figure out which of those three forms would be easiest to fill in those variables by looking at this graph. All right. So first of all, standard form is very difficult to go into standard form straight from a graph, because a, b, and c have really no correlation to any of the points of a parabola. They don't have really technically a straight number straight from the vertex we can put in, and the x-intercepts don't really go into straight standard form. Vertex form we could go into if we had both of the x-intercepts. Do we have that in this graph? No. So the best one, like Connor said, the best form that we're going to use for this is we're going to use vertex form, because we have a vertex and we have several other coordinates, 1, 2, 3, 4, 5, 6 other coordinates. So I can use any of those other 6. In fact, in this model, what I'm going to do is I'm going to choose to use this one, because that one is probably at 0 and 2. So I know I have a coordinate. I'm going to estimate that's at 0 and 2. And my vertex looks like it's at about 2 and, we'll say 22. A little under halfway between 20 and 25. So I have 2 points, and one of them is the vertex. So I can go right into vertex form, just like Connor said. So I'm going to rewrite that down here. Oh, actually, no, vertex form's at the bottom. That works out great. So first of all, let's fill in our h and k. What are the values I'm going to put in for h and k from the 2 coordinates? I'll rewrite the coordinates beside it so we don't have to keep scrolling up and down. We have our vertex, which is at 2 and 22. And we have a point. So I'm just going to put point A, we'll call it, at 0 and 2. I need to replace h and k with numbers. Of these 4 coordinates here, which are the numbers I'm going to use to replace h and k? 2 and 22? Okay. Oh, okay. What am I going to put in, first of all, for K? 22, right. The K refers to the Y value of the vertex, and in this case, we have 22. So our very first step, AX minus H, and we're going to put in positive 22. Right here, that was the value we used, the Y value of the vertex. All right, what am I going to put in for our H? 2? Okay. Now, here's the tricky part when you go to plug it into vertex form. If I put in, now remember, this negative sign stays. I'm just replacing H. If I put in negative 2, am I going to have the right answer? No. What should I replace it with then? Just 2. Okay? Choose blue. We're going to replace our H, just the H, not the negative sign, with our 2, which is technically a positive 2. Okay? So we'll put positive 2 in here, just so we can try to make sense of this. And that is the X value. So if you guys notice, I only replaced the H, the negative sign still stayed. What's going to happen is that's going to simplify to become X minus 2 plus 22. And now if you notice, that makes sense when we go from vertex form to graphing. Normally we have negative 2, so that means we go in which direction? On the x-axis, which way would I go, left or right? For the H. Right. We always think opposite, right? So if we take a look at our vertex, it's 2 points to the right, which makes sense now that we've plugged in positive 2. It actually ends up looking like a negative 2. Remember we did vertex form into a graph before? This is just putting in the numbers now. So we've replaced H and K. What other, I have 3 other variables. I have a Y, an A, and an X. What can I do with point A? So I have another point, and they're an X and Y value. I could have used any point on the graph. I just happen to choose that one. Okay? So because I chose that one, I can replace, this is an X value and a Y value, so I can replace the X and the Y in our equation. So what that means is our Y will now be replaced with the number 2, and our X will be replaced with the number 0. So we're going to plug this in. 2 equals A, 0 minus 2 squared plus 22. Okay? Last thing I have is our A value. I don't know what it is, and looking at the graph, it's pretty hard to just figure out what the A value is going to be by looking at this. But since I have values for all of the other variables, I can solve for A now. So I'm just going to carry out that math, solve for A, and then plug A back into the equation. So I'll show you what that means. 2 is equal to negative 2 squared plus 22. Negative 2 squared is 4. That says A times 4. I'm just going to write it the way you're used to seeing it. A times 4 is also the same as writing 4A. If I move the 22 to the other side of the equation, it becomes negative. So this becomes 2 minus 22 equals 4A. Negative 20 equals 4A. Yeah, I divide both sides by 4. What is it? Negative 5. Okay, so my A value is negative 5. So they still wanted an equation. I'm not done. They didn't ask me to just solve for A. They wanted an equation. We're going to put it in vertex form because, like we said, that was the easiest way to do it. So vertex form, Y is equal to, my A value is what? There we go, negative 5. Minus, what was the H? Yeah, looks like a negative 2. And finally, our K, 22. And if you take a look, that's supposed to be a positive sign. If you take a look, we now have a full equation in vertex form. Oh no, I can't get rid of it. Oh, there it is. Let's not say that they asked us for an algebraic model, but they wanted it in standard form. Okay? So, let's say they wanted it in standard form. I'm going to rewrite my vertex form. Y is equal to negative 5 x minus 2 squared plus 22. If they wanted it in standard form, what would I have to do to this vertex form equation? Expand and simplify, exactly. So, I take my bracket, and because it's squared, yes, I heard it, Drake. I double the base. Next step, what am I going to do? Anyone remember what this is called? Foil, that's right. I'm going to foil my two brackets. Let me do this quickly. This becomes x squared minus 4x plus 4. I skipped a step there. Once I do that, what's my next step? I'm going to factor it. I have to distribute something. Yes, I need to distribute my -5 to each number inside of the brackets. So we foiled first, so we had firsts, outsides, insides, and last we multiplied all those, got this answer here. Next thing I'm going to do is take this -5, and I need to distribute it to each of the numbers inside of the bracket. So y is equal to -5x squared plus 20x minus 20 plus 22. So finally, in standard form, this is my standard form of the equation we've just made. We have a value for A. What is our value for A? Exact same value for A in our vertex form. So both of the A's are always going to be the same. What's our value for B? 20. And value for C? Thanks, Drake. Sorry to keep you up. Okay. So we have our standard form. Excellent. We've got that down. Yeah. So we have our standard form. And they've asked us now, with this model, they want us to predict when the rock or the slingshot, the rock we shot from the slingshot is going to hit the floor. What does that mean? What other form do we need to turn this into? That's right. I got to turn it into factored form because I need to find out the two zeros. We know one of them's over here, and something is over here also. Okay? We don't actually know what it is. By looking at the graph, we can't get an exact number, and they want an exact number, so we're going to take our standard form of our equation here, and we're going to factor it. When we factor it, we'll have our two zeros. So let's rewrite it again. Y is equal to -5x squared plus 20x plus 2. I go to factor this. I find the factors of the first number. Actually, since we haven't really worked with the first number being a negative, I'm going to factor out a negative. So I'm going to take a common factor of -1 out of this. When I take -1 out, we'll then be working with a number that's positive x squared. Because I know I haven't shown you an example with a negative x squared, that is. So our value here, so -1. And we're going to find the factors, of 5. What are the factors of 5? Factors of 2? 1 and 2. Am I able to find -20 with those? No. So what can I do? What have we learned? So we're not able to factor it the way we'd learned earlier. So hence why I made you guys write that quiz. We need to use a quadratic formula to solve this. So we had our standard form. We figured out we weren't able to factor it the way we've been doing the last chapter. So we plugged these numbers into our quadratic formula. Plugged in positive 20 for the B, -5 for A, and 2 for the C. Carried out bed mass. 20 squared is 400. -4 times -5 times 2 is 40. 40 plus 400 is 440. 440, the square root of 440 is 20.97. I then split it into two different equations. Carried out the rest, and our two x's are -0.097 and 4.97. Which of the two do you think is where the rock is going to land? 4.97. That is where the rock's going to land. It makes sense when we look at our graph that it's a little after 4 is where the rock